We will now disassemble the handle. It looks heavy. First, cut out the battery. There's a flip switch. Dial down and take out the battery compartment. This toggle switch looks very interesting. It has 3 buckles. One here, one on the left and one on the right. Look, 3 buckles. One switch controls 3 buckles. Do you see that? All 3 are moving. This is the battery compartment. Let's dismantle it. There are 4 screws in the battery compartment. It's an interesting structure. Did you notice that I just unscrewed the screw from a tilted angle? There is a hole at the vertical angle just to get the screwdriver to go through here. Then install this screw at a vertical angle. But my screwdriver is thicker. Can't get through. Fortunately, we can also unscrew it from the tilt angle. Did you see the toggle switch I just said? To spring compressions and 3 buckles. Interesting structural design. Look, there are some touch points on this part, embedded inside the part. These 2 touch points correspond to the positive and negative poles inside the handle. In appearance, only the touch point can be seen, but in fact more circuits are covered with plastic. These 2 touch points go through the metal wire behind the back and are embedded inside the plastic. It's embedded very tightly and appears to have used an ultrasonic process. We can't break it, because the 2 have become one, which is the characteristic of ultrasonic technology. Next is the handle. No screw hole can be seen on the surface. Then it is very likely that a buckle or glue is used. You can see there's a slit there, so we start there. We can see the same. It is indeed a buckle inside. And we're just going to take the shell off along it. Separate the shell and base to see the internal structure. Let's take the topping off. There is also a screw on the back. Well, it fell out. It came off pretty easily. It was a latch. When it is inserted, it is very firm. Take it off, and the bracelet is easily removed. It's an antenna with a housing. Here's a signal cable and a soft cable. The interface of the flexible cable. So let's start with the first half. That's the part that carries the keys. The PCBs. A spring is used on the front, which looks like a customized special spring. The lower half is a large loose circle, and the upper half is a small tight circle. It's a very attractive button. Letter A. It looks printed. But from the back, it's actually two-color injection molding. Unlike the A just now, this one is printed. The purple circle with no other colors on the back is the printing process. Put it together for comparison. Do you see it? It is bonded with double-sided tape. Look at the glue on both sides. There is also a pin here. The function of this pin, I think, may be to connect the metal signal cable on the shell. The signal wires are attached to the housing. When you get close, just touch. Then look at the overall plastic parts. Let me say what material it is. It says PC. The surface has been piped. You can also see a thin clamping line. At this location, very fine molds. Sharp edges. And look at the base. We see a lot of double-sided tape processes. From the battery compartment just now to the soft cable here, you can see the double-sided tape. And here, the floppy cable at the edge. Common FPC flexible cable. Look at this. It's been taken down. It is the carrier of these sensors, an independent structural piece. I haven't seen the motor yet. Continue to disassemble. A lever. Remove this joystick. The rocker is independently assembled on the base. Remove the cable. This is the cable for the power supply. This could be the wire for the motor. Let's continue. The cylinder here should be the motor. A finger wrench. It does what it does with a spring. The simplest spring. Realize the action of finger pulling. The force of the spring is very well controlled, and the finger is very smooth to use. Through the principle of Hall sensors, there's a magnet. detect changes in magnetic poles, and determine the movement of the finger. There's a magnet in the middle shaft. Everything else is mechanical. There is a PCB in the corresponding direction. The magnet rotates, the PCB detects the magnetic pole change, and the principle of the whole sensor. Surprising design. And look at this black bump. Is it a soft rubber stopper? Oh, I think I got it. It's a spacer that cushions the finger. There's also a cushion. When pressing down, it touches a black bump. When it rebounds, there is another soft cushion that plays a cushioning role. Protect the edges of this plastic shell. See how its motor is fixed. The motor is also glued here by double-sided tape. However, double-sided tape is not a high-temperature resistant material and will lose its viscosity after high temperature. But the motor will generate high temperature when it vibrates for a long time. This structural design may pose risks in the long run. PC and 1 OGF are written on the case of the base. The materials of the lower shell and the upper shell are different. The upper case uses a pure PC. The colors are also different. The surface lines of the upper shell and the lower shell are also different. It's granular. The advantage of granular is wear resistance. Try to scratch it with your fingernails. You can feel it. The top half of the shell is matte textures. Both are made through molds. It's one shot. Okay, we're done disassembling.